Hi guys. So in this video we are going to look at a coding challenge which is a 2D board. So this is the given 2D board and we have to find the legal move. For example, this is 0. So we can go left, right, up and down but no diagonal movements. So if 0 is here and it has -1 and up, you cannot move there, you cannot move. So -1 is represented as a stone or a wall, so you cannot move once you hit a wall, but apart from that you can move anywhere. So this is the representation of 2D board wherein these 0 are the places where things can be moved and -1 is a place which is blocked or a wall where you cannot move. So what is the output is, for example, if you have been given a coordinate of this 0, you have to say uh, uh, from 4 what are the legal moves which can happen. So for this guy you can move to these coordinate, these coordinate, these coordinate, but not these coordinate. So for this there will be three possible moves. So you have to write a function which will take a board, and based on the board it would take the coordinate of whatever place, for example this, and then you have to return the tuple with xy coordinate of the legal moves. In this case you cannot move above, it's a wall. You cannot move on right because there is nothing. You can move down and you can move left. So if given coordinates are this, then these two coordinates would be the legal moves as I am showing it on the screen. So let's do this. This is a simple problem and these are the sample inputs wherein we have the board and the x and y as a tuple. So these are two parameters given to the function and this is the result. I have already created the test case over here which we will check at the end once we implement. Now first we have to figure out the algorithm. What would be the algorithm? So we will break down the problem in the algorithm and then we will start solving it. So step number one is, once we get the coordinate, we have to find what is up, what is down, what is left and right. So assume that this is x and then this is y. So you have the x axis. Imagine this is the place. So if you will do if you will do x -1, if y is constant, you will get here, and x plus 1 will get you here. Same way, if you keep x constant, y -1 would get you here and y plus 1 would get you here. So this way you would be able to get these four corners around here. And then any value less than this is not allowed. Array index out. More than this, I mean more than whatever is the ceiling, would be array index out. So that way we will check if the value is out of the index, then we will say it's not a legal move. For example, this any value plus 1, like y plus 1 is not a legal move, so we will not include that. That is how maximum each cell would have four places to be returned. But in case if one of any place which is -1, we will not include that in the answer. And any place which is out of the boundaries or the limits of this matrix or 2D array will not be included. So the remaining will be included. This is our algorithm and the approach. Let's start solve this. Let's start to solve this. So I have the board and then I have the tuple. So I would say T for tuple. Now from the tuple, I would grab x and y. This would be our x and y, which we are assigning here. Now we have a board. So let's think, from the board we will pick these value and then we will pick the four values, which should be the surrounding values. So how we are going to do that? So let's go with the board. It is a 2D board. So we will do this here. P1 is equal to x plus 1 and y. Point 2, let me do this here. Point 2 will be x minus 1 and y. Now point 3 and 4 will be x, y plus 1 and y minus 1. So these 4 would be the probable move at the max, whatever is the value of this. Now the question is, can we always return that or not? So if we have to append this, let's append this in the probable position. So I would say PPS probable position, which is an array, and array has these values, and we would return this here, probable position. We are taking baby steps over here for now, and we will say print whatever it is returning. We will print. We will pass on a board to this, and then we will pass on some coordinates. For example, 1 comma 1. So when we pass 1 comma 1, we don't have to run this for now. Yeah. So we get the probable position, which are these four for 1 comma 1, but we have to get 2. So this is mainly elimination. This algorithm is called as the conditional elimination. So we will eliminate the value which are either minus 1 or which are out of the boundary. So let's first check minus 1, because that would be easier. So what we are going to do here is, to make it easy, what I am going to do is loop over for coordinates in probable position if coordinate is equal to board, and then we have x and y. So we'll say x and coordinate y. Oops. If this value is minus 1, then we will pp dot remove coordinate. So this will give us index array of bound error, because one of these value, if it goes over limit, then we have to check that condition first before doing this condition. So let's run this first and then see. Let's see what happens. So we already got, so we don't want this. What will happen is we have to use this. Syntax error happens. List indice must be integers or slices, not tuples. Let's see what is coordinate here. It is 2 1. So what we are trying to do here is we are trying to find 2 and 1. And what's the problem this guy is having? This would be 1. So we got the 0, we got the 1, we got this here, and then we got it here. This is good, this is good, this is good, this is good. Why is it having trouble? Okay, so probably we have some problem with the if. So what we'll do is we have board, and if we say board has coordinate, and then this coordinate is actually 2 values wherein we get the PP. So what we'll do to make things simple, we will unpack this and we would say X and Y. So here we would get board X and then board Y. This will give us a value. Now if this value is -1, we are not going to include that. What does that mean is we will eliminate the value. So there are 2 ways, either you eliminate the value or you add it fresh in the next value. So once we run this, we got it. So the answer is really good. We got it in a single easy way, easy money. Now, most complex part or the simplest part is what if the value goes out of here? So we will see that 5, 1. For example, if the value is 6, 0. So 6, 1, 2, 0, 1, 2, 3, 4, 5, 6. 6 and 0, 1, 1. So these guys have this move, this move, this move, but there is something which is going out, which should not happen. So 6, 1, we will get index array out of value. Let's try that. See, so we have to get that value as well. So how do we do that? You would say if x, which is number of rows, is greater than or equal to length of board, or y is greater than or equal to length of board's first row. That would be our column. So if we have 5, 0 to 4, 4 plus 1, 5. As soon as it would become equal to the length, it would have the trouble. So we will say continue, which means if we do continue, we would have to remove that. So we'll remove that and then we will do continue. Or to first let's run this, then we'll further optimize it. And cool. So we got 60 all these options. So let's check this condition again. For 60, we got 51, 62, and 60. For 61, we got it. Let's say for 60, what do we get? So -1 is coming. So we have to again check if the value is less than the boundary. We have checked the greater sum, but not the lower sum. So again, we will eliminate if x is less than 0 or y is less than 0. So this will sort our condition. And yes, we got what we wanted. We got the probable positions first. From them, we eliminated the value which were above or below boundary. So we picked the length, and index can go equal to the length. But whenever the value of x or y is greater than or equal to that length, we have just terminated it. Now this logic can be appended here as well. We can say another or, and we could put it here itself, and we can remove this. So this is one mega condition. If any of these condition meets, it would go down. So it would start checking from here, all the way here, and then it would come here. So it would never ever hit the index array of bound, because whenever the maximum bound or hits here, it would be removed. Cool. So now we have the test cases. We have different test cases, which are these values, all this. So this would be our bot, this would be our input, and these are the probable legal moves, which are the output, expected output, as we are returning the probable moves or probable positions. I have kept this as the test data, and we have this. We don't need this method over here, sorry. And then we are looping it over. So this tuple first here is the coordinates, which is the given value. Second is this expectation. And then this is inside the test data. So we will have our function here. Now, once we have the function, we will pass the board and then the given coordinates, and it should give us the actual. Once we get the actual, then we'll compare the actual with the expected. If it's equal, that's fine. Otherwise, something might be breaking, which it is breaking. I believe we'll fix that, no worries. In 5.3, we have expected these two values, and I guess that is where it failed. So 5.3, let's see what do we get here. With 5.3, we are supposed to get 4 values, which we already got. Probably with 5.1, we are getting 4 values. Let's see again. Why I'm doing again, I have no idea. So testing with given 1 1, we got this. Testing with 5 3, we got this. Which got failed. 5 2 5 4 4 3 6 3 with 5 3. Okay, let's see if this third condition passes or it fails. So it says given is 5 1. These are the expected value and it is failing again. So I believe the failing is happening because of the format in which we are testing, because the method is returning an array. Yes, and we are expecting the array, but both the arrays are equal or not, that's the question. We'll print the actual as well. We will do f print. Okay, this is happening because of the sequence and nothing else. So our solution is good, and it was given that the solution can return it in any order. Here it is written. So we are good, and we are done. So please subscribe to my channel if you like this kind of coding challenges. I have shared the link for the code base. So grab that link and hope to see you in the next video. Thank you. Bye.